In this lesson, we are actually going to look at a different form of quadratic equations, which is the turning point form. So by the end of this lesson, you should recall how to apply vertical and horizontal translations of the basic parabola. You should understand and identify the critical features of a parabola from the turning point form, and finally, apply the turning point form of the quadratic equations to sketch a parabola. Now, I would like you to take out your class pad. I want to recall what I did in the first lesson. Alright? So, getting your class pad, you need to sketch the following using the class pad. Y equals to x squared, y equals to x squared minus 2, y equals to x squared plus 3, y equals to x minus 4 all square, and y equals to x plus 1 all square. Pause the video for about 5 minutes, plot it, and then let's have a look at your answer. Now, this is what I've done. The blue one is the basic parabola y equals to x squared. You can see the translation up and down, left and right, when I actually ask you to plot x squared minus 2, x plus 3, x minus 4 all square, x plus 1 all square. So this is the horizontal translation, this is vertical translation. Alright, let's have a look. In general term, when we translate y equals to x squared, which is the basic parabola, up and down or left and right. So when we have x squared, y equals to x squared minus 2, and y equals to x squared plus 3, one actually moves the basic parabola down, the other moves the basic parabola up. So, looking at this, if you take away 2 or any constant, it is moved down by that unit. So here, y equals to x squared moves down by 2 units. Alright, whereas this one, y equals to x squared, moves up by 3 units. Alright, so just a summary. When you have got y equals to x squared plus k, or y equals to x squared minus k, if k is greater than 0, the basic parabola moves up. If not, the basic parabola moves down. Since it moves along the y-axis, just up and down, the turning point will still have x coordinate as 0, whereas y will be just plus or minus k. Then the axis of symmetry is still x equals to 0. The next situation, we have y equals to x squared minus 4 all square, x plus 1 all square. Now, when we have x minus 4 all square, the basic parabola moves right by 4 units. Whereas when you've got y equals to x plus 1 all square, it moves left by 1 unit. Alright? So as a summary, the horizontal translation of y equals to x plus or minus h all square. So for x minus h all square, y equals to x squared moves to the right by h. The turning point is plus h, 0, and axis of symmetry is x equals to plus h. So now, for x plus h all square, the basic parabola moves to the left by h. The turning point is now minus h, 0, and the axis of symmetry is x equals to minus h. Now, how about when we combine x plus h all square plus or minus k? Again, I would like you to use your class pad to actually sketch this for parabola. Pause the video for a while, sketch it first, and then check your answer against mine. Now you can see that the basic parabola has moved left by 3 units when it is x plus 3 all square. And then when it's x squared plus 2, it moves up by 2 units. When we combine both x plus 3 square and x plus 3 all square, and we add the constant 2, it actually combines the horizontal movement and then the vertical movement. Alright, so every point of the basic parabola moves to the left by 3 and then moves up by 2. So we can actually use y equals to x plus or minus h square plus or minus k to represent a basic parabola, the translation of basic parabola. The next slide, you would have seen this before, is just a basic summary when I combine x plus or minus h all square plus or minus k. Alright, I will actually leave it for you to read this slide. I won't bother going through it. I want to explain the next slide a little bit better. Alright, so let's have a look at quadratic equations. You know the general form is y equals to ax squared plus bx plus c. You have been introduced to the root form. Y equals a, brackets x plus or minus m, brackets x plus or minus n. And then now, this is a new thing you've learned. Turning point form. Y equals to a into x plus or minus h all square plus or minus k. Alright, let me explain the turning point form. So when you have y equals a, x plus or minus h all square plus or minus k, x plus or minus h all square gives you the horizontal translation. K will give you the vertical translation, and combining both, you will know the coordinate of the turning point. Therefore, this is called the turning point form. The A is actually the dilation factor, and it's also a reflection. Alright, I will talk a little bit more about dilation factor and reflection a little bit later. At this stage, I want you to concentrate on y equals to x plus or minus h all square plus or minus k. Now, let's have a quick look at key features of parabola again. What you really need to know when you actually sketch a parabola. You must know the shape, the concavity. So it could be a U shape, which is concave up, or an N shape, which is concave down. So at this stage, we are concentrating on concave up. Alright, so here you can see that you need the axis of symmetry, you need the x-axis intercepts, or the roots, the y-intercept, and the turning point. Now, with all this information, you should be ready to sketch a parabola. Right, let's now do some examples. First, let's sketch y equals to x minus 2 all square minus 4. You are asked to state its turning point and axis of symmetry, and determine its x-intercepts and y-intercept, and then sketch the parabola. So let's start off with stating the turning point. The turning point is 2 minus 4. You know that x minus 2 all square is moved across to the right by 2. So therefore, the turning point is x is 2, and then move down by 4 is minus 4. And then the axis of symmetry is x equals to 2. Now, for y-intercept, this is when x equals to 0, therefore y equals to 0 minus 2 square minus 4. So therefore, minus 2 all square is 4, 4 minus 4 is 0. So the y-intercept is 0, 0, which is the origin. Then the x-intercept All right. Bear in mind that you could have 1, 2, or no x-intercept. So let's have a look. This is when y equals to 0. Therefore, x minus 2 square minus 4 equals to 0. So x minus 2 all square equals to 4. X minus 2 equals to plus or minus square root of 4. So x minus 2 equals to plus or minus 2. X equals to 2 plus or minus 2. Therefore, x equals to 0 or 4. 2 plus 2 is 4. 2 minus 2 is 0. So the x-intercept is 0, 0, and 4, 0. Alright, armed with this information, we should be able to sketch the graph. So now we know that the axis of symmetry is x equals to 2. Let's start off with the axis of symmetry. X equals to 2. Turning point is 2 minus 4. 2 minus 4. And then we know y-intercept is the same as x-intercept is here. And then the other x-intercept is 4, 0. So it's 0, 0, and 4, 0 here. So we can join the points and sketch y equals to x minus 2 all square minus 4. Right? So next one, I would like you to pause this video and try doing this. Pause the video for a while, sketch the parabola, and then compare your answer to mine. Alright, the turning point is minus 2, minus 11. And then the axis of symmetry is actually x equals to minus 2. Part B, the y-intercept. You know that y-intercept happens when x equals to 0. Therefore, y equals to 0 plus 2 square minus 11, which is 4 minus 11 is minus 7. Therefore, the y-intercept is 0 minus 7. And then for the x-intercept, you know that happens when y equals to 0. So x plus 2 all square minus 11 equals to 0. And x plus 2 all square equals to 11. X plus 2 equals to plus or minus square root of 11. X equals to minus 2 plus or minus square root of 11. Therefore, the x-intercepts are minus 2 plus square root of 11 and 0. And minus 2 minus square root of 11 and 0. Now, you are not expected to calculate the exact values of minus 2 plus square root of 11 or minus 2 minus square root of 11. What you need to know is estimate the location of these two points. So here you know that plus square root of 11 is between square root of 9 and square root of 16. Square root of 9 is 3. Square root of 16 is 4. Therefore, you know square root of 11 is actually 3 point something. So therefore, you know this point is actually at the positive x-axis. Alright? Here, you know that it will be negative x-axis. Alright? So all you need to do is approximate. Let's start off with the axis of symmetry. X equals to minus 2. So x equals to minus 2. And you know that the turning point is minus 2, minus 11. And then the y-intercept is 0, minus 7. So approximately here. And then you know that the x-intercept, 1 is somewhere around here. 1 would be somewhere around here. Remember, because of symmetry, the distance from here should be about the same as the distance from there. In fact, I plotted this a bit too far away. That should be around here. So this should be label y equals to x plus 2 square minus 11 and label this point. This point will be minus 2 plus square root of 11, 0. This point will be minus 2 minus square root of 11, 0. So you see, you don't actually need a calculator to do this. All you need to know is your search and estimate the location. 2 more examples to go. Let's start off with this one. Try this. Pause the video for a while and see if you can sketch this. Alright, we know the turning point this time would be minus 2 plus 5. And then the axis of symmetry is x equals to minus 2. And then part B, the y-intercept, happens when x equals to 0. So y equals to 0 plus 2 square plus 5. Therefore is 9. So it's 0, 9. What about x-intercept? So happens when y equals to 0. So x plus 2 square plus 5 equals to 0. X plus 2 square equals to minus 5. Now, because you cannot have a square root of minus 5, so there is no x-intercept in this case. Alright, so you need to know the turning point, the axis of symmetry, and y-intercept to sketch the graph. So, axis of symmetry, x equals to minus 2. Y-intercept is 0, 9. And the turning point is minus 2 plus 5. So this is how you do it. Y equals to x plus 2 square plus 5. Alright, one more example. Again, I would like you to try this first. So you should know that the turning point is actually 1, 7. And then the axis of symmetry is actually x equals to 1. Y-intercept. So for y-intercept, x equals to 0, y therefore equals to 0 minus 1 square plus 7, which is 1 square is minus 1 square is 1, 1 plus 7 is 8, is 0, 8. And finally, x-intercept. So y equals to 0 at x-intercept, x minus 1 square plus 7 equals to 0. So x minus 1 square equals to minus 7. Again, there is no solution for square root of 7. Therefore, there is no x-intercept. Alright, let's draw this. Axis of symmetry, x equals to 1. Turning point is 1, 7. 1, 7 actually, that 7 is too low. Let's make this here 1, 7. And then the y-intercept is here, 0, 8. So let's sketch that. Parabola of y equals to x minus 1 square plus 7. Alright, you know how to sketch the parabola now and know how to identify the key features or the crucial features of a parabola using a turning point form. This is the end of the lesson.